कोई नहीं बोलेगा, कोई नहीं बताएगा, है ना। लेकिन तुम कहीं जोश में आके बबीता जी को मत बता देना भाई। ऐसे
hello students. So today's class will wind up with the first numerical, and maybe let's start with the second numerical too. So let's continue with this. So this is a numerical which we started on worm gas. Go back to the next slide. So we noted down the data, the RPM, the material for wheels, whatever data was given in the numerical. Noted down. Step 1, I think we solved in case of worm gear, solve worm wheel, that is the spur gear or the helical gear, whichever is there. So that is the weaker member. So hence we start from there itself. So in first step we assume always the weaker member is the gear, and in the first step also it is required to be we find that the number of teeth, the velocity, and stuff, right? So first step here is very simple. Second step, we found the tangential tooth load for on general basis, and with respect to the Lewis equation, they're not yet found. We were on the process. So one by one, I think we were finding, and we have noted all the parameters here. So now all it's left is to substitute these values in the equation. We're continuing with that. So sigma d 82.4 searching the symbols here.
Gombe
into CV. This is my value of CV.
Value of CV.
Of CV into B. I have assumed 10M into Y. Y is Y into Y. I think this need to be calculated. This is Y into Y. Y is here nothing but Y2. Y2 also I think is yet to be found. The Y2 is yet to be found. Let's go back to the PPT here. The value of Y we can extract from this thing here. So Y we can extract from here. Value here is 36. I think number of teeth is 36. So depending on value here, we need to take it from the respective formula here, y. Table 12.5, 12.6. Point 2.8. Okay, let me open it. And here. Okay, here I think it's there over here. This is a different table altogether. We need to input this. Forgot to input this in the presentation. We can do that now. Okay, so this one here. Okay, so 12.28c. So we need to refer for value of y only in case of worm gas. We need to refer to this table. So the number of teeth were known, and if they were exact, no, then we could take from this table. But since it is not given for worm gear, let's assume this table. So what form of teeth have we assumed? Form. Okay, the form also is not given, I think, in the question. Right, the form of teeth also is not given. Check the question once again. No, the form is not given. So again, here we are free to assume our own form of gear. So let's assume 14.5 degrees. So for 14.5 degree, y value is 0.1. So this is from 0.1. This is assuming 14.5 degrees. 14.5 degrees full depth involute. Then from table 12.28c. So you get the y value from there. Okay. So that means this is equal to 5 into 0.1. This is 0.3142. Okay, so we have this, and right. So I think we have everything here. Now only this thing is to calculate. So let's substitute first. So this value here will be in place of y into m, or let me just do it like that. Okay, so and instead of ft here, I'll substitute this thing. So let's calculate this. 1000 into 18 into 1.8 over 0.745. So this you get 4297, 0.82 over m. This will be over m. Let's copy this. This is from step 1, part 1 of step 2. So this equals this whole thing here. So with this we can simplify and calculate the module. Right? So simplify. Let's simplify. You can solve on your calculator meanwhile, and post the results in the group chat. It's 82.4 times 3.05 times 10 times 0.3142. So I'm putting the left hand side as it is. This is equal to, I'm getting here 789.68 65 over the whole thing here. Yeah, so you guys also calculate and see what value you get. And here also this is m over m time m to the power 2. This will be a superscript. Okay, let's simplify. Multiply on either 5 because there is cross multiplication. This is 42970.82 times 3.05 will be 131.06061 m, no, not m, plus again that into 0.0754. We're getting 3240 m equals 789.65. I'm getting here as m cube. This will be m cube. Right, ft is different, huh? Let me check that. 1000 into 1.8 divided by 7297.0.82. No, I'm right. So ft is right. So someone is posting in the private chat. The value of ft is correct. You can check in this formula here. You can substitute this and see. Oh yeah, you're right. Velocity is 0.0. Right. 0.07. Small mistake. Oh yeah, thanks for correcting that. 1000 into 18 into 1.8 over 0.0754. Yeah, you're right. This will be 8.22. Right. You're right. Thanks, Vinayaka, for correcting. So we need to replace these values. So that means this also changes. So this into 3.05. I think one decimal shift we can see in all the parameters. Okay. So now we can just plug this value in the equation and we can find out the value of m equation. So equation and the degree is 3. Value of a 789.65. B is 0. C is 3 negative minus 32400. And D is 1310613. So module, I have got it as 12.99, 6.5, and yeah, 6.5 and 6.5. So we can take the highest. So whichever value you get highest by solving this equation of order 3, you're getting module around 12.99 and 6.5 and 6.5. So you can keep it as the highest value, whichever we get. The highest is 12.99. So we'll approximate this to 30. So module is found. Once we have found the module, let's go to the next step. The next step is the proportions. That is the gear parameters. So you also find the key dimensions of both worm and worm. So let's say for worm, no, we'll find the diameter D1 Where is D1?
Hey.
Table 12.6. Okay, first this is for the gear. For the worm, yeah, it's here. The pitch diameter D1 is we'll take this value here, 7.54, which is in terms of module. Okay, so pitch diameter, board on shaft. This is step 3. Proportions. Proportions. Here we come to worm proportions first. Worm proportions. This is, we have got it from table 12.26. So here only some key dimensions we'll find out. So number 1, let's say pitch. Pitch dia is equal to D1. The D1 is 7.54 m plus 28. Okay, so this we have got from the table. You can see here the value. Here for D1, 7.54 plus 28 mm. So we will take the one which we know, there is a module. And again for the particular angle, that's 14.5 degree. For that respective value, we need to calculate. Okay, so this is 7.5 times 13 plus 28. So we're getting 126.02. So only some key dimensions, like even addendum, let's say HA. So this in tests and all, what happens is they usually ask you to find only very key dimensions or put it all together. Yesterday's test, some of you saw that we had asked you totally to skip it. So this is equal to module, that will be 13 mm. Only some key dimensions which will be useful for us in the next step. This is of worm proportions. Let's take worm gear proportions now. This step is just a plug and play kind of a thing. So you can skip it. So worm gear proportion, but some dimensions will be required, like D2 here. So for D2, there is the pitch dia. Let's write that out. Pitch dia. This is for gear. Is D2. Right? So for D2, there is nothing specifically given. You can check in the data handbook. So that we already know what to do. There is M Z2. So this is a module times the number of teeth. That we already know. So we can just substitute there. So module we just found is 13, and into Z2 number of teeth is 36. And come to know this is 13 into 36. .468 mm. Okay, so an outside diameter. So this is given by the formula here, DO2. Some key dimensions. So we can give it a subscript. So this is equal to D2 plus 3.1854 M. So this is D2 plus 3.1854 M. So this equals 468 plus 3.1854 into 13. This equals 13 into 3, 6 plus 3.854 into 13. We're getting 509.41. Like some key dimensions like this you find and find this off. And one more, just one more we'll find. Let's put phase width. We have here phase width, which is denoted as B for gear. Phase width is given as B is equal to here 7.48 M plus 6.35. 7.48 plus 6.35. So this is in terms of M. So that means this is equal to 7.48 into 13 plus 6.35. This comes around 103.99. Okay, so B will take this one henceforth wherever if asked somewhere. So that's enough for the key dimensions. Let's move on to the next step. Okay, so the next step is the finding the wear load. So for finding wear load, FW, the wear load needs to be considered. So let's plug this here. So FW this is step 4. Wear load is given by FW. So subscript this is equal to D2 BK. B and K as given in equation 12.62a. 12.62. Okay. So D2 I think we already have. This is with respect to gear. Therefore, we already found the values required for the gear. So D2 is right here 468 into B also is found 103.59. That is B. And what about K? For K he has given here load stress factor for depending on the gamma angle. Gamma is the helix angle of the worm. What is the helix angle of the worm? I think we have noted. Let's just check once. No, I don't think it's given in the question also. Let me check. No, it's not given. The helix angle also not given. So this step I think was not required because that was not asked. Only thing was asked was heat generation. So since it's not given, we are free to assume. So let's assume 25 and up. Material was hardened steel and phosphorus bronze. We can take this value here, 0.824. So K value 0.824, and just put another step. A from table 12.30, and also assuming gamma use gamma much, I guess. Use gamma. Assuming gamma is 25 degrees. This is helix angle. So this comes down to 468 into 103.59 into 0.824. This is the 39947.62 newtons. This is not required, but still we are following this steps. Stepwise. Not asked. We do when it's asked. So step 5 is efficiency. Efficiency. Go back to the presentation here. Efficiency is using the bars formula. So this is required before we go to the next step. You see, next step is about heat generation and dissipation. So heat generation dissipation is what we needed to find in this problem. But before that, we need to find what is the efficiency, because those values are required here. You can see. Okay, efficiency is here. So new value. Therefore, here the new value is here, the efficiency. Therefore, we need to find the efficiency before we proceed. Okay, so this is using the bar formula. Let's just type this in the program here. New. So efficiency new equals to is tan of gamma inside bracket. We have 1 minus mu minus mu, again tan gamma over mu plus tan again gamma. So let's go back to the PPT. Okay, so let's find one by one. Gamma value here. For finding gamma, there is another equation. We need to find where that gamma is. Let me check. Okay, here the lead angle to find the value of gamma if not given. We just assumed in the previous step is 25. Let's not do that. We'll take it from this equation here. It says 1 over pi d1. Right? So we have d1. Let's see if we can use this. Instead of this now. Gamma here is let's say tan inverse function. Where is the tan inverse function? Just put it here. Tan gamma is equal to from this equation 1 by 1 or L. Looks like L. Yeah, there is L. L is the lead. Instead of that, what can be done? Okay, L is over here. So L can use that as M2. There's no M2 on. Oh, L is pi M2. What is M2? There is no M2. Or we can equate this D2 by Z2. D2 is D2 by Z2, which means it is this input here, and yeah, your tan gamma will come around here as MZ1. You can do the small math in the dead handbook. Both values of L and this thing you can substitute. We'll come to MZ1 over D1. Okay, we can use this here. So that means this is equal to, let me put it in the next step. We are no longer assuming here. Let's put for this value. So now this equal to M is 13 into Z1. Z1 is 1 over D1. D1 I think we found in the step 3. Yeah, 126.02. 126.02. So that means the value of gamma is tan inverse of that value there, 13 divided by 126.02. Then tan inverse of this D1, right, with D1, right? How much is D1? Okay, so this we have got 5.89 degrees. So for 5.89 degrees, we will go back to 5.89. It will come to this value range here. And for hardened steel, phosphor, bronze, the value is this 0.549. We'll take this here. This is 0.549. And then this will change. 468 into 103.59 into 0.4549. This is 266.15.59 Newton. So now we have got gamma as a as the helix angle exact value. So this is not directly given in the dead hand book. So you need to mix a couple of equations here. So I'll show you in the dead hand book. So here you see you have tan gamma as L by pi d1. So L again is given here. Okay, so let's say mz1, m2z1 was the second module here. M2, don't know what's M2 yet. So we'll just insert this as mz1 here. So that means pi gets cancelled, mz1 by d1. So that will remain. Okay, I hope you got it. How did I get that tan value here? Let me put this entire thing here. So I use a combination of these two equations. We're using the combination of these two equations. I've just found out. So this P1 here written as this MZL written as pi mz1. So pi mz1 substituted into place of L. So therefore pi gets cancelled and you get mz1 over d1. So that's how I've condensed this equation to get this one here. This value. So mz1 by d1. So that's how.
D1.
Hope you got it. Please let me know in the group chat if you have any doubt. Okay, we'll proceed. So we have gamma. Now to find mu. For mu, we need to find the velocity. So it depends on velocity. So therefore, let's find the velocity first. For velocity v equals how much? So velocity this value. So this into 13. This is equal to into module 13. Let's calculate this. 0.0754 into 13 is 0.98 meter per second. So that's our velocity. So that means for this value of velocity, we need to refer what is that? Okay, this value here. So we have to use equation 12.60a for velocity between 0.2 and 2.75. So therefore, we have to carry out this operation here to find mu. Just copy this. Mu equals
Efficiency of the worm gate.
action
Step 5.
0.422 0.0422 over so V R, capital V, small v, R. This R is a subscript. V R. Then again we have a power of 0.28. So 0.28. This will be the power. Okay, so we need to use this equation for the velocity, and this is 12.608. Okay, so again for this value VR is a separate formula given here in this PPT. You can see here VR is this equation here, pi d1 n1 and 1000 cos gamma. So let's input this. It is pi d1 n1 over cos of 60,000 cos down. These both will be in subscript. Okay. So this again is equation. Why 60,000? Only 1,000 here. Dropping velocity only 1,000, not 60,000. It's in meter per second. Okay, this is just given in terms of equation. Let's substitute this. So this is equal to, let me substitute as it is. So d1 here is, what is d1? 126.02. Put a multiply symbol here into, again into n1. What is n1? 1,440. One is 1,440 over cos gamma. Gamma is what is gamma? 5.89 degrees. 5.89 degrees. Just calculate this value here. So pi into 126.02 1440 over 1000 into cos 5.89. We are 573. We are not greater than. We should get around these values. Maybe here it is 60,000. Let's see what happens if I substitute 60,000. 126 point divided by 60,000. Then I'm getting 9.55. So I think this is 60,000. Okay, make this small change in the data handbook. So in data handbook it is given as 1,000. You see here it is given as 1,000. Just change this here as 60,000. Change this as 60,000. Even in the data handbook, you just make this small note, change this to 60,000, similar to how we do in the while finding the velocity. Okay, change this here to 60,000. So then we're getting value as 9.55 meter per second. I think this is an error in the data handbook. Change it to 60,000. Okay, so now we have found VR. So that means we can find the value of mu. So let me copy this. So mu here is VR. We can input is 9.55. So instead of this, just paste. So that means this here will be 9.55 or 0.28, 0.0422 divided by this is I'm getting the value of mu as 0.0224. Okay. check if you got some different answer. So we have all the values. You can substitute and find. So gamma here is 5.89. The mu is 0.0224. Again, gamma 5.89. Mu 0.024. Gamma 5.89. Okay, so let's now find out what is the efficiency. Okay, calculate quickly. Let's see how much you get. 5.89. 1 minus 0.0224 to tan 5.89 over 0.0224 plus tan 5.89. I'm getting 81.97 percentage. So this is the efficiency. This is the efficiency of this particular worm and gear arrangement. Okay, so we have found efficiency. Last step. Let's finish this problem off. Heat dissipation. Heat dissipation given by Q. This also has two parts. You need to find heat generated and dissipated. So step 5. This is heat generated and dissipated. We need to find both of them. So part 1 here. So this is also split into two parts. Heat generated. Heat generated is given by this equation here. So Q F V Fn Vr cos. Only Fn I think we need to find value. Fn, yeah, Fn is here. So let's quickly find out. So Q, Q G. So G is heat generated, which is given by is equal to fraction mu Fn. N is a subscript, and V Vr is Vr. R is subscript. We have Vr, then over divided by cos gamma, cos and gamma. Right. So this is equation 12.638. I think. Yeah, 12.638. So right, we have all values except Fn. So only Fn we'll find using another equation. I'll check it out. This equation here. So Fn is here. Okay, so all these things we'll make it to come over Ft, because we know Ft can make all of this come under Ft. So Fn equals Ft over cos theta, cos theta, cos gamma minus mu sin gamma. So this is Ft. This we have taken from equation 12.56i. is 12.56 I. Okay, let's calculate this. The FT we already calculated. What is FT? Oh, this is FT. Okay, not calculate. Let me just copy the whole thing here. So FT we are not yet calculated. So let's complete the calculation. So this is 4297.98.22 divided by 13. So this is 33,054.48 newtons. Okay, so we have all the values. Let's calculate this here. Fn now. So Fp is this value here. Then cos theta. What is theta? So theta is not known. Theta is not known. For theta, we need to head back to the data handbook again. Find where theta is. It is given here. Very small equation. 12.56d. You have tan theta equals tan alpha cos gamma. Let's do that. So tan theta equals to tan alpha cos gamma. Okay, so that means our theta. Welcome to the RHS. This is tan alpha. We have chosen 14.5 degree, the full depth involute angle, the form of teeth, and cos gamma. Gamma is 5.89 degrees. So that means theta is equal to tan 14.5 into cos 5.89. The tan inverse of this is theta 14.43 degrees. Right. So we have found theta. So theta is known now. 14.43 cos gamma. Gamma is 5.89. Mu is what is mu? 0.0224. Then gamma again is 5.89. Okay, so let's solve this. This divided by cos 14.43 into cos 5.89. Minus 0.0224 sin 5.89. So Fn value I've got as 34394.98 is in newtons. So now I have Fn, so I think I have all the values. So let me find finally what is the heat generated. So mu is 0.0224 into Fn 3439.44 into Vr. Vr is Vr 9.55. 9.55 over cos gamma. Gamma is 5.89. Okay, let's calculate this. This into 9.55, 2.0224 divided by cos 5.89. Okay, so we got 7396.71. This is in joules. So we'll stop here today. Next part we'll do in the next class.